And we're going to start out with the notes since it was Wednesday yesterday. So, a radian, what is happening? Why is this jumping like that? Is an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle and has a measure of 1 radian. We'll get a little bit more into that in a minute. So far we've pretty much been working with degrees. We may have had a radian thing here and there. I don't remember. Again, my classes all run together at this point in the year. But basically, sometimes you're given degrees and we need to convert to radians. Sometimes we're given radians and we need to convert to degrees. One of the formulas we're going to get in a minute, we have to be in radians. And a lot of times the trick part of it is that they give you it in theta and you got to be able to convert it. So our conversion factors for degrees in radians so degrees to radians so if I'm doing that, then the conversion is pi over 180. If I'm going from radians to degrees, then it is 180 over pi. So basically it's the degrees or radians of half the circle is what that conversion factor is coming from. In its like simplest form. So if you're given degrees and we want radians, I want pi on top, okay, because our answer is going to have a pi in it. So think about all of our radian values on the unit circle have a pi in them, right? Pi over 3, 3 pi over 4, things like that. They all have a pi in them. So if I ultimately want it in radians, I've got to be able to see that pi. Now, I'm also going to tell you, depending on what you're doing, there are going to be times that you're going to multiply that pi through. But if I'm just asking you to convert, it's going to have the pi left in the answer. So no decimals, they'll say as a fraction. With radians to degrees, I want degrees on top. And so 180 degrees, obviously, I would have that degree on top, and the pi's need to be able to cancel for my radians. And it'll make more sense when we look at examples as well. So degrees will end up being like typically a whole number because the pi's cancel, and then the other numbers will typically just reduce down pretty nicely, but they come out to all kinds of things. But they're usually not decimal numbers, I guess is where I'm going with that. All right, so the next thing, obviously up here, it talks about intercepts and arc of the circle and all of that. So the arc length of a circle, the length S of the arc intercepted on a circle of radius r by a central angle. So that's just like the angle at the middle of the circle, like we mentioned in that first definition up there, of measure theta radians is given by, and then it's this formula, S equals, what does that mean? R theta, where theta is in radians. So that's going to be the key thing to remember. And I point that out in every class that I do arc length and even area, because the area will also come up the same way, because we have an area formula that goes with this information. Obviously, we should know the basic area of a circle from geometry, even back to Algebra 1. But that being said, the most common mistake on these problems is not forgetting the formula. It's not like, not like setting the stuff up right. It's not putting theta in radians. Like, they will do everything right, but not convert theta to radians. Okay, so make sure you remember to do that, because that's the big thing. I think it was Algebra 2 the other day. Can't remember if it was them or if it was pre-cal. Anyways, regardless, one of them, right before I handed them the quiz, I said arc length and area, theta has to be in radians. And like 3 people didn't do it. Okay, so emphasize that, like ingrain that in your brain. Theta is in radians for arc length. So the other thing is area of a sector, which is the thing that goes with arc length here. It's like how we find area if we're given that information instead. And so we have 2 different ways we can write this formula. They'll give you the same answer either way. First is area equals 1/2 r squared theta. Again, with theta in radians. Or area equals 1/2 r times s, where where S is r theta from up here. Okay, and again, theta still would be in radians when I do that. So if I've already solved for S, I like this bottom formula better. But if they haven't asked me to find arc length and it's simply just an area problem, then I use this top one. So either way is fine. If you just want to memorize one and not have to worry about multiple, then just memorize that one. If you're like, I want the one that's easier, then the bottom one. But if you do the bottom one, you have to find arc length first. Does that make sense? All right. So the first problems here are asking us to convert the degree values into radians. Okay? So and it says to leave answers as multiples of pi. So radians can be a decimal value, but for the sake of us converting, again, they need to have the pi in them. So number 12 is 30 degrees. Now, that's a value on the unit circle, right, that we already know. And what is it? What is 30 degrees in radians?
Pi.
That's 60. Cut it in half.
Cut it in half.
Pi over 3 divided by 2. All right, so my unit circle here, which is not really a circle right now. So the one that you told me, you said pi over 3, which is here. And then I've got these other two values here. 30 degrees is half of 60. So pi over 3 divided by 2 is pi over 3 times 1/2, which would be what? Pi over 6. Okay, so I could just use my unit circle and say, okay, I know this is pi over 6, but let's say that we forgot or we're not super confident or whatever. Y'all were very good with the degrees around the unit circle, okay, and overall good with the other stuff too. But let's say that you're like, well, I know I'm confident with degrees, but I don't remember radians. Well, you can sit there and you can like literally figure them all out if you forget how to count them or forget what they are or whatever. So I'm going to show you just really quick how we would do this one as well. So if well, I'm sure you've done these in science before, but I do like the T-chart thing. So I use that conversion factor up here. So I'm going degrees to radians. So that means pi needs to be on top because I want the degrees to cancel. So it'll be pi over 180. Goes here. So then the things that I like to do are like both of these have a 0 on them. So I can cancel that. And then 3 goes into 18 6 times. So this is pi over 6. So you got to at least be able to reduce, because if you can't reduce, then you're going to end up giving me a decimal, and I'm going to mark it not completely right because just leave it in terms of pi. But not to say you can't use your calculator if you can't figure out like how many times, like, 15 goes into 180. Like, if you can't think of that, just grab your calculator and do it super fast. Obviously, I was just making up a random number there, but let's see. 14. 120 degrees. And a lot of times when I write down the problem, I'll go ahead and just make the T-chart. Now, 120 is also a value on our unit circle, but I'm going to pretend that I've forgotten it. I don't have a unit circle in front of me or whatever. And so I'm going to do the conversion. So again, pi over 180, because then that causes degrees to cancel. So think about it. Whenever you have something top and bottom of a fraction, you want those units to cancel. So the degrees are canceling in this situation. And then the zeros here, since they both have a 0 on the end, I can cancel those out, essentially dividing by 10. So then now I've got 12 pi over 18. Can that be reduced anymore? What can I do? So I can still go farther than that if I take something bigger out. Yep, because I can take out a 6, which would give me a 2 on top, times pi over, take out a 6 on the bottom, and that gives me 3, so 2 pi over 3. Let's see, 18. This one is negative 315 degrees. So negatives are fine. That just means my final answer is going to be negative. I do everything the same way. So T-chart here. So I've got pi over 180. So in this case, nothing, I can't just cancel a 0 off. So I'm going to see if I can take out I know 5 will work. So if I need to start out with something like that, I can take out a 5. So 315. Honestly, if I have a number this big, I'm going to grab my calculator and I'm going to start seeing what the biggest thing I can take out is. I'm actually going to try 15 and see if that works. So if I take 15 out of 315, I'm left with 21. So right now I've got negative 21 pi over, I know 180 can be divided by 15, and that would be 12. but can I reduce it farther? What can I take out?
3.
A 3, so that's going to give me negative 7 pi over 4. And now, that makes sense. 315 degrees is a value on my unit circle. Okay, now this one was negative, but all I have to do is throw in that negative sign at the end. I could have done it if I knew that 315 degrees was 7 pi over 4. Then I can just be like, well, if it's negative, then it's got to be negative 7 pi over 4. Makes sense? Now, right now they're being nice, and they're giving us all ones that are on our unit circle, which is kind of annoying. I'm going to make up one that would not be on our unit circle. 250 degrees. So, again, pi over 180. So I can take off the zeros from here. And then is there anything that I can do now to reduce the 25 and the 18? Are there any common factors that I can take out to reduce it any farther? Nope. So this one, pretty big number, but that's fine. 25 pi over 18 would be the answer to that one. Okay, so sometimes they're really big, and that's fine if that happens, obviously. Any questions on degrees to radians? All right, then let's see here. Radians to degrees now. Again, they're giving us a lot of stuff here that's on the unit circle. Let's see. I'm trying to get one that's not. 34. Hold on. I don't want to do that one yet. 36. 11 pi over 15. So, not a value that I have on the unit circle, but I can obviously convert it. So the difference here with these ones and the ones that we did is when we're going degrees to radians, there's nothing here in this bottom part of our T-chart. But when I set up to do radians to degrees, the 11 pi is going to go on top and the 15 is on the bottom. Okay, some people like to put everything in the top box and then they end up doing something wrong because they don't end up dividing by that 15 when they convert. So now I want radians to degrees. That means degrees needs to be on top. So this is going to be 180 over pi. So pi's will cancel. And the nice thing with these is at this point you get to just plug it in your calculator because we don't leave degree measures in fraction form. Radian measures we leave in fractions, degrees we don't. So at this point I would just do 11 times 180 divided by 15 and I get 132 degrees. So the stuff on top gets multiplied, stuff on the bottom gets divided. Just like it does if you've done conversion charts in science, which I'm sure at some point in physical science you did. And then if you're in chemistry, well, you should have been doing them. Yeah, correct. And so I was like, I'm going to go back to physical science and say, should have done them in physical science. Should have done them at some point before. I do them very briefly in Algebra 1 also with a couple things that they have early on, and they're like, why are we making a chart? I'm like, trust me, you'll thank me later. Let's see, another one. 38, negative 7 pi over 20. So that was why I skipped 34 because it was negative. I wanted to do a positive one first. So, again, just like we had the negative number, the negative degree value up there, and we converted. The final answer is just going to be negative. If it starts negative, got it in negative. But this one sets up same way. So I'm going to do the negative 7 pi, and the negative could go top or bottom, doesn't matter. And then over 20. I'm going radians to degrees, so that means that I need degrees on top. So 180 over pi. And again, pi's cancel. And I like to show that because typically mistakes made here are people using the conversion factor wrong and then it not canceling stuff out like it's supposed to. So I've got -7 times 180 divided by 20. And that would be -63 degrees. Well, they do, but since I'm not leaving it as a fraction, I just typed the whole thing in my calculator. But yeah, I could have canceled the zeros and then just done -7 times 18 divided by 2. That would have been fine also. So when you're going to degrees, you can use your calculator. On the other ones, you just have to be mindful that you can really only use that to help you reduce because you've got to have your answer as a fraction. Now, obviously, there are situations if it was something like 720 degrees, right? That's obviously not going to end up giving you a fraction, but it's going to have something with a pi in it because 720 degrees is all the way around twice. So that's going to be, 4 pi. So it doesn't necessarily have to be a fraction, but there's no decimal values in there. It's got to be a whole number with a pi symbol. That's what I always tell people. All right. See, the rest of the stuff here in this section is the arc length problems. And again, this section, they do the stuff with the degrees, minutes, seconds, and they're converting that to radians, but we're not going to, that. You just don't use that going forward, so we're just skipping that stuff. So if you're like, why are we jumping 30 problems? Well, that's why. All right, this says find the length. It says to 3 significant digits. This isn't science class. I don't care about that. Of each arc intercepted by a central angle theta in a circle of radius r. So some of them, they give us our theta in radians. Some of them, they give it in degrees, and you've got to convert it. So just make sure we're paying attention to that. So 68, and all of these just want us to find arc length. They're not asking us for area. I don't know. Are there not area problems? Oh, no, there are. Okay. So 68R equals 0.892 centimeters. Theta is 11 pi over 10 radians. So if they don't have it written in terms of pi, because sometimes it's not, they will put RAD to represent radians so that you know you're working with radians, okay? So otherwise you're going to see a degree symbol and you'll know you need to convert it. So formula for arc length is S equals R theta. That's the very first thing I would do every time I do one of these problems is I would write that out, S equals R theta, so that you don't get confused. So this is 0.892 times 11 pi over 10. And now this answer obviously can be in decimal form. They say 3 significant digits. I usually just say 2 decimal places is what I normally say. So I got 0.892 times 11 pi divided by 10 is 3.08. And then we want to keep those units on there. The units are the whatever's on the radius, so that's centimeters. And so that would be your answer to that one. So these ones are just formulas, essentially, that you need to know to be able to plug them in. Now with 72, they give you R equals 71.9 centimeters, and then theta is 135 degrees. What's the problem with this one? It's in degrees. So this is a value that's on my unit circle, which if you have it in front of you, obviously you can quickly figure out what it's supposed to be. But I'll just do the conversion really quick. So pi over 180. I say really quick. I'll have to reduce this thing down really quick. So let's see, 35, or not 35, 135 divided by 15 is 9. So that would be 9 pi over 12, which I can reduce again. So that'll be 3 pi over 4. And again, you don't have to show that if you have your unit circle in front of you or if you just know that value off the top of your head, but I'm just working it out so that we have a few more examples to look at of conversions. So S equals R theta. So S equals 71.9 times the theta value, 3 pi over 4. And then I just multiply that, so 71.9 times 3 pi divided by 4. And that gives me 169.41 centimeters. Now, if you rounded it to the nearest whole number because they say 3 significant digits, that's fine. I don't care. Make your choice. But I usually just say 2 decimal places is sufficient on that. Now, let's see. Area problems. This section has a lot of problems in it. All right, area. Find the area of the sector of the circle having radius r and central angle theta. Express the answer to the nearest tenth. So a lot of times, just so that you're aware, what I will do is I will actually just tell you in one problem to find the arc length in the area rather than giving you 2 separate problems for that. Okay, because one, if you want to use the 1/2 RS, then you need to have already found S. So I'm going to do it with both formula. I'll do one with one formula and one with the other. I'm actually going to go ahead and do area here on this one as well, even though I didn't ask for it, just because I've already got S and we're running low on time. So area is 1/2 RS. If I want to use that formula, when I do another one in a minute, I'll use the other formula. So this would be 1/2 times 71.9 times this S value that I found, so 169.41. And your calculator will have already found, will already have this value in there because that would have been the last thing that you had just done. So if you just hit multiply, it'll take that previous answer, so it's actually holding in case you rounded, which, again, I'm not going to be that picky. If you're off by like a decimal place or 2, which is all you're going to be off by, you're not going to lose points, okay? Because I'm going to assume it's just a rounding thing. So I just did the answer times 71.9 times 0.5, or I could have said divided by 2. Nope, that's too many decimal places. There we go. And so the area is 6,090.3. And then this one would have been centimeters squared. So this would have been the area for that problem. Okay, so a lot of times, like I said, I'll give you one problem and it says to find the arc length in the area because their instructions are kind of elaborate. I make it simple and to the point. Okay. Now, I'll use the other formula. I'm going to choose one that's already in radians because of time. So 100 R equals 59.8 kilometers. And theta is 2 pi over 3 radians. So the formula, if I have not already found S, which again, you can do it either way, even though this problem doesn't ask you for arc length, you could find arc length first if you prefer that method. So I'm going to have area equals 1/2 R squared theta. So that's the formula if I don't have S. And then I just plug in, nice and easy. So 1/2 times 59.8. If I can write. squared times 2 pi over 3. And then just type that in. So 59.8 squared. I'm going to go ahead and divide that by 2. And then multiply by the 2 pi over 3. And when I do that, I get 3,744.8 kilometers squared. So any questions on that? All right, I'm going to go ahead and give you your problems. I'll give you some time tomorrow to work on them since we didn't have any time today. But the next section, like I said, is pretty short also, so we may actually do that, and then I may just give you the whole time to work. But 11, 19, 29, 37, 67, 71, and 99.